Hello everyone and welcome back. So how do we leverage on-push change detection? Going back to our reducers, we are going to avoid this by not using clone deep. And let's remember, this is an optimization that really we should only apply if we are planning on using on-push change detection and if our application really needs the extra performance boost. It's important to keep in mind that the default Angular change detection mechanism is already blazing fast and it will probably be sufficient in the vast majority of cases. So what we are about to see in the remainder of this section should be really seen and used as an optimization if necessary. So let's see how we can do this. Let's first take, for example, this reducer here of the send new message action, and let's take a look at the state that we are reproducing. As we can see, the state, the store data state, is not a deeply nested object. It has a few properties that are maps that map a number, an ID of a participant in this case, to a given participant object. So this is not a deeply nested object. So given this, let's go back here to our reducer of the handle send new message action. Let's look on this reducer for modification operations. So here we are modifying the current thread, so we are reading the current thread from the threads map using the payload thread ID, and then we are pushing into it a new message ID that we just created here. So one of the modifications is we are modifying a given thread. Another modification is we are pushing a new entry to the messages map. But let's have a look at what we are not modifying. For example, we are not modifying the participants. We are not modifying any of the participants, and we are not adding or removing properties to the participants map. Actually, we are adding a new message here to the messages map, but we are not modifying all the existing messages. And also, we are only modifying one of the threads, one of the existing threads in the threads map, but we are not modifying all of the threads. So for example, in the case of the participants, completely cloning all the participants here at this moment would not be necessary. We can take the current participants property and we can point to it directly in the new state that we are producing, because we know that the participants were not modified. It's okay to point to previous data that was previously existing in the store if the data was not modified. We don't need to create a copy of the same data. In the same way, in the threads object, we could potentially keep all the existing threads here in this threads map, except one, the current thread that we are modifying. A similar thing would happen here in the messages map. We would indeed need, like in the case of the threads, to create a new map, but the values of that map would not need to be deep clones of the messages. We could reuse most of the messages. So instead of doing a deep copy of the messages map, we could effectively create a shallow copy of this map where we would keep references to all the existing messages, and then we would add to that new map a new reference to a new message that we have just created, but we would not have the need to clone all the existing messages. So what would this look like? Let's implement what we have just described. So the first thing is we are not going to use clone deep, but we do need to provide here a new object. So let's just initialize here a new object, and we are going to annotate it saying that this needs to be of type store data. So now we get here a compilation error. For example, we need to specify here the participants. So here, as we have seen, we can reuse the exact same participants that are available in the state object, because we know that we are not going to modify the participants. Now let's fill in the other properties. So one of the properties that we are going to fill in is the threads map. So here, the threads map, we know that we are taking all the threads that are there and we are going to modify one of the threads. So we can start by copying the existing threads map over. So we are not going to reuse the whole map, but we are going to reuse most of the objects existing here in the state.threads map. In order to do this shallow copy, we are going to use object.assign because that's the ideal case for it. So we are going to take an empty object and we are going to copy into it all the references to all the threads that are available in the state.threads map. So we know that we will be mutating one of the threads before this reducer function is finished. But let's first populate here the last property that we need, which is the messages. So again, we are going to want to reuse all the message objects that already exist on the store data, but we don't want to reuse the messages map itself. So let's start by creating here a new object, and inside it we are going to fill it in with all the properties of state.messages. So we are effectively creating a new object where each ID, each property which is the ID of a message, is pointing to the exact same message object to which the previous version of the state was pointing. So we did not deep clone all those messages. We simply created a new object that points also to all those messages. Now let's have a look at the modification operations that we were doing. We were going to the threads map and we were taking a given thread, the current thread, based on the current thread ID. Using it, we were going to the message IDs property of the current thread and we were mutating the array by pushing a new message ID. Instead of doing that, what we are going to do is we are going to replace the existing thread ID object. So here we are pointing still to the ancient thread. We are going to create a new thread object by copying the existing thread that was here. So how can we do that? We are going to access the position of the current thread and we are going to assign this to a new object. We are going to copy across all the properties that we had from the current thread. We are going to do that using object.assign. We are going to start with an empty object and we are going to copy all the properties of the current thread. So we are going to access actually the state object here so that we are sure that we are pointing to the previous object that represented the current thread, and we are going to copy across all its properties. So the end result here in the new store state is a new thread object that is effectively a shallow copy of the current thread, but it's not exactly the same object. Now what this line here is doing is we are retrieving a reference to the new thread object that we just created, which is a shallow copy of the previous version of the current thread. Now, taking this new copy of the current thread, we are going to modify its message IDs. But take a look, here we did a shallow copy, so this is still pointing to the message IDs of the previous store state. So we really don't want to call here any push modifications. What we want to do is we want to start by creating a copy of the array that we had there. So we are going to do the following. We are going to take the existing message IDs array and we are going to create a copy of it. Let's do that using the slice operator in this case. So because this is not an array of objects, just copying it around or concatenating the result would be the same. But if it would be an array of objects, this would effectively copy the references of the objects without duplicating them. So now we have here effectively a new array of message IDs. So to this new array, we can push a new message ID. We can modify this new array of message IDs because it's not the same array that was associated to the previous current thread on the previous store data state. This is a new array that we are creating here. So the same goes here to the messages map. This is not the original map that we received back from the store. The messages here is a new object that we copied here. So this one we can easily modify without any problem. And remember, although all of this can be a bit tricky, we are sure that because we are using ngrx store freeze that we cannot mess this up, so we don't have any compilation errors here in case that we try to mutate the original store data, but we will get an immediate error at runtime. So let's quickly try out this new reducer with our application up and running. So let's switch to the browser. Remember, this was the send new message reducer, so let's send here a couple of messages between users. We're simply going to say here hello Bob, and we're going to reply hello Alice. So as you can see, everything is working as expected, and if we open here the console of one of the chat windows, we can see that there are no error messages here, so everything is still working as expected. So we are sure that our code that we wrote here is not mutating the original store data. To summarize, what we are doing now is, instead of creating copies and producing a new state as a completely separate object, we are as much as possible always pointing to the data that was not modified. This way we are passing the same reference objects to the view layer. By ensuring that the same references are being passed, we will be able to leverage on-push change detection. We're going to see how to do that in the next few lessons. Right now, we need to apply the same logic to the other reducers that we have here. That's what we're going to do in the following lesson.